Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 162. Please turn to it. Page 162. Problem number 4. This problem that you see there on page 162 is the exact same problem that appeared in the first edition of the revised GRE. We have already solved every single math problem out of this book. We're just redoing these problems. If you're interested in watching the original solution, you will find the original solution to the problem on day number 71. Just type in the tag revised GRE math day 71 and you will find it. Let's see what it has to say. We are given a graph here. The solid line represents the export, as you can see, and a dotted line is the import, the bottom one. The question simply is, for which of the 8 years from 2001 through 2008 did the export exceed imports by more than $5 billion? The only reason why you will get this question wrong is if you are in a hurry and you don't pay attention. Otherwise, it's quite straightforward problem. You just have to look at each of the year and see if the difference is more than 5. That's all. For which of the 8 years did export exceed import by more than $5 billion? That's it. So here are our years: 2001, 2002, 2003, 2004, 2005, 2006, 2007, and 2008. Of course, in the real exam, we wouldn't be so damn silly as to write everything out. I'm just doing it for your benefit, so that it's easier for you to actually follow my work. And here are the answer choices: A, B, C, D, E, F, G, and H. I'm going to erase this part here because I need the room. So here's our exports, and then we're going to subtract the imports, and finally we'll have the results. So exports, again I'm reading it from the chart. If you look at the solid figure there, export for all of these years, make sure you begin with 2001 and not 2000. They're asking from 2001. If you look at this solid line, you will see that for 2001 the exports are 10 billion, and then it goes on 13, 14, something less than 9 for 2004, something less than 9 again for 2005, something less than 16, something less than 16, little under 16, and then we have a 7 and then we have something more than 12 and 11. Now let's look at the imports. The imports are little under 2 billion for 2001. Again, make sure you're looking at 2001 and not 2000. And then we have little over 3 billion. Then we have something under 4. Then we have 4. Then we have 5. Little under 6. Then we have a 7 and a 5. And now we are looking at their difference. Is what we are interested in. Export minus imports, their difference. So let's begin then. 10 minus something under 2 is going to give us something over 8. So that one works. But 13 minus a little over 3 is going to give us something little under 10. That works. 14 minus something under 4 is going to give you something a little more than 10. That works. Something under 10, something a little bit less than 9, minus a 4 is going to give us something under 5, and that's not going to work. We're looking for a difference of 5. We're looking for the export has to exceed the imports by $5 billion at least. It says for which of the 8 years did the export exceed imports by more than 5 billion? Well, I shouldn't say at least 5 billion, more than 5 billion. Even if it exceeded by exactly 5 billion, that wouldn't have been good enough. It has to be more than 5 billion. Again, something less than 9 minus a 5 is going to give you something less than 4. That's not going to work. Something little less than 16 minus something little less than 6 is going to be approximately 10. That would work. It's going to be approximately 10. Something a little more than 12, something a little over 12 minus 7 is going to give us something more than 5, so that would work. And 11 minus a 5 is going to give us 6. So that would work. That's it, those are your answer choices. Make sure that you check mark every single answer choice, otherwise you will not get the credit. These are tricky ones. This type of question did not exist in the old GRE. These questions have multiple answer choices, and if there are 4 right answer choices, and if you only check mark 3 of them, you're not going to get 3/4 of the credit. You're not going to get any credit. If there are 5 answer choices, you make sure that you check mark every single one of them. So here the answers are A, B, C, and F, G, and H. These two, D and E, do not count. As you can see, they are under 5, and that's it. But other than that, there is not really much to explain here. That's it. We're done. We're going to move on to the next problem. Problem number 5 on the following page. Page number 163, problem number 5, something that we did on day number 72. If you're interested again in the original solution. Day number page 163, problem number 5, day number 72. Here we are asked to find the average of 9 changes in imports from year 2000 to 2009. It says, which of the following is closest to the average of the 9 changes in the values of imports? Which of the following is closest to the average of the 9 changes? There are 10 years, and therefore there are 9 changes in the values of the imports between consecutive years from 2000 to 2009. Let's see what we can do here. Let me first do a simpler version of this question. Instead of doing 9 changes, let's start with something simpler, something that's easier to deal with. Let's do it 5 changes and see what happens. Let's first do a similar question. Similar. I didn't mean to say similar. I meant to say let's first do a simpler version. So here we have 2, 4, 7, 11, 16, and 22. So here in the original problem, the problem that is given to us, we have 10 years and therefore there are 9 changes. Here, instead of 10 years, we have 6 years. Year 1, 2, 3, 4, 5, and 6. 6 years, these are the figures, and since there are 6 observations, there are going to be 5 changes. And the question is, what's the average of the 5 changes? Let's do it out first. What's the average? There are 6 changes. There are 6 observations, therefore there are 5 changes. Well, I don't have to write all of this down, you can see here. So the 5 changes are going to be from here to here, the change is 2. From 4 to 7, the change is 3. From 7 to 11, the change is 4. 11 to 16, the change is 5. And 16 to 21, the change is 6. Since they are equally spaced, a difference of 1, since they are equally spaced, 2, 3, 4, 5, 6. Therefore, the average is going to be the middle. The average of these 5 changes. These are the 5 changes. And these are the 6 observations. Six observations. I don't know why I have to write everything down and then I get sloppy. 6 observations. OBS is the abbreviation for observations. The question is, so now the average of the 5 changes here is 4. The question is there a quicker way? Do we really have to do it like this manually to figure out each individual change for each of the 2 consecutive years, each of the pairs of 2 consecutive years, and then figure out the average of these changes? Is there a quicker way? The answer is yes. Is there a quicker way? The answer is yes. What we have to understand is, I'm going to continue on the top here, the average of the 5 changes is going to be no different than any other average. How do you find the average of 5 numbers? If you are given 5 numbers, how do you find their average? You add them up and you divide by how many numbers we have. So that's what it is. The average of 5 changes is going to be the total change. Total of all of these changes, 2 plus 3 plus 4 plus 5 plus 6, total change divided by the number of changes. Now the question is, how do we figure out the total change? One way to figure out the total change is to go 2 plus 3 plus 4 plus 5 plus 6, and this is your total change. That's one way. Another way to figure out the total change is to realize that the total change, here this is where the tricky part comes in, you have to pay attention. One way is to figure out the total change is to simply add up all the changes, which there's no big deal here, everybody knows that. But another way to realize that we can figure out the total change is to understand that the total change has to equal the final figure minus the initial figure. If you add them up, 2 plus 3 is 4, 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14, 14 plus 6 is 20. Total change is 20, which is same as 22 minus 2. Therefore, the total change, I need the room now, so I need to raise it. So the total change is simply the final figure minus the initial figure. The final figure in our example was 22, the initial figure was 2, that's your total change, and there were 5 of them, which is why it's 20 over 5. But of course we already knew the answer. The average of 5 changes was 4, which is exactly what we find here. That's what we need to do in this problem. In this problem we have 10 changes. Let's find out. So in order to figure out the total change, we have to look at the initial figure. We don't have to worry about all the figures in between. They're looking for the average of the changes, average of the 9 changes over this 10 years period, the average of the 9 changes in the figure of imports. So what's the final figure for the import? The final figure is going to be 2009, and look at the imports and tell me what is the final figure. And I see the final figure is 9. The final figure is 9. Imports for 2009 is 9, and imports for 2001 rather, 2001 is, how much is the import? Little under 3. Little under 3. Therefore the change is going to be little under 6. Little under 6. So look at this as a total change is equals to total change equals to the imports for 2009 minus the imports for 2001. And that's, as we just said, is 9 minus a little under 3 or a little more than 3. 2001 is, it's a little bit more than 3. It's a little more than 3. Divided by, how many changes do we have? We have 9 changes. So 9 minus something more than 3 is going to be something under 6 divided by 9, which is same as something under 2/3. Something just a little under 2/3 of $1 billion. Something just a little under 2/3 of $1 billion. Something little under 2/3 of $1 billion is $660 million that we see there. In one of the answer choices they give us, oh actually it should be as 660 is put down, but the closest that we come here is 640 million, and the answer is A. The answer is that the change is going to be just a little under 2/3 of $1 billion, because the change is, the total change is little under $6 billion, a total change of $6 billion, little under $6 billion divided by 9 changes, that's little under 2/3. That's a minus sign there, right there, is a minus sign. That's all. Now one last thing I'm going to show you here, just to understand why it is that we have to figure out only the final change and not worry about the intermediate figures in there. And the reason is this. The first change, the very first change that we're going to talk about, that we're going to understand, it says for which of the 8 years from 2001 to 2008 did the export exceed the imports by more than 5. Oh sorry, I'm reading the wrong question. Question number 5, sorry. Question number 5 says, for which of the following is the closest to the average of the 9 changes in the value of imports from 2000 to 2009? From 2000 to 2009. From 2000 to 2009. So from 2000 to 2009, the very first change is going to be the imports in 2001 minus the imports of year 2000. That's the very first change. Second change is going to be the imports of year 2002 minus the imports of 2001. The third change is going to be the imports of 2003 minus the imports of 2002, and so on and so on and so forth. Finally, we'll have the imports of 2008 minus the imports of 2007 plus the imports of 2009 minus the imports of 2008. That's how it's going to go. Now watch what happens. Watch what happens. As you start adding up all the changes here, what we should realize here is that here I see the imports of 2001 and here I see the imports of 2001. This is a negative figure. Negative, this I stands for imports and 1 is for 2001. So here I have a negative figure, here I have a positive figure. These two are going to cancel each other out. Similarly, I see the imports of 2002 and I see the imports of 2002 appearing here again, but this is a negative. So they cancel each other out. Similarly, here I see 2008, the imports of 2008, and here is the imports of 2008 again. This is a positive figure, this is a negative figure. These are going to cancel each other out. And this is going to cancel itself out with the previous 2007. This is going to go away. And what are we left with? What we are left with here is the final figure, 2009, minus the initial figure, right here, minus the initial figure. And that's why when we're looking at the 9 changes, we don't actually literally have to do out the 9 changes. What we have to understand is that in order to figure out the sum of the 9 changes, all we have to do is to look at the difference between the final figure and the initial figure. Difference between what you started out with and what you ended up with. That's your total change. And once we have the total change, we just divide, this is our total change, we divide it by how many changes we had. We had 9 changes. So 9 minus something more than 3 is going to be something under 6 divided by 9. Something under 6 divided by 9 is going to be something under 2/3. Something under, and of course these are figures in billions of dollars. So something just a little under 2/3 of $1 billion. And I was going to actually write it here 666 or 667. 660 is good enough. And the only figure that comes close to 660 is 640. That's your answer. Alright? I'll see you tomorrow, okay? Bye now.